in chapter 5, we're moving from the drug sources, where we get drugs from, to the forms, how those come to us or how they're administered. So our learning outcomes, we're looking at the 3 drug forms, solids, liquids, and gases, and what determines them, and then some different terms that go along with it, homogeneous and heterogeneous, and then looking at the different types of liquids and solutions, so different categories of those liquid forms, and then a difference between solid and semi-solids. So we have 3 different drug forms. We have gases, we have liquids, and we have solids. Now the form of that drug determines a few different things. One is the route of administration, which is just how the drug is given. So, we're not going to be able to administer a drug that's in a gas form the same way we would administer one in a liquid. So, if it's in a gas, it has to be inhaled, whereas if it's a liquid, we don't want them to inhale a liquid. So it determines the route of administration. It determines what's called pharmacokinetics, and we have a whole chapter about pharmacokinetics, but that's just how the drug moves through the body, how the body kind of interacts with the drug. So how does it get places in and out of the body? And then it also determines the pharmacodynamics, another chapter all about that, which is the effect the drug then has on the body. So the form that the drug comes in can change how it interacts with the body. So the form, a lot of times drugs come in different mixtures, and that's mixing different gases, mixing liquids. So a couple of terms that go along with that. So again, just combining 2 or more of these substances. Now each is still going to retain its own characteristics. So we're not mixing them together, doesn't like change them. It's just putting 2 or more things together. So then the mixtures can either be heterogeneous. So hetero means different. That means they're not going to be equally distributed. So like mixing oil and water. They don't really mix, so the oil separates away from the water. Sometimes that happens whenever we mix these drugs together. They don't really mix very well. Or they can be homogeneous, which means the same, which means that they would be equally distributed. So then, mixing doesn't become such an issue here. We don't have to really worry about them settling because they're all kind of equally mixed up. With our gases, essentially a gas is a liquid in vapor form. So gases in one form are in a liquid, but they don't stay there. They evaporate and become vaporized. So these can extend indefinitely. So it's really hard to contain them. So we have specialized containers in which they are pressurized and kept within them. Otherwise, they just go all over the place. So in that way, diffusion becomes an issue. So they diffuse, they move from where there's a lot of it to where there's less of it. So storage and transportation becomes an issue because they have to be cooled to their liquid state. Again, they're just gas forms of a liquid. So to store them, because they have no definite shape or volume, they have to be cooled and then placed into a container, and then it can be released from that container. So it's actually transported in that liquid state. And they are stored in these pressurized tanks, which is going to help keep the temperature low so they don't evaporate and go to that gaseous form. So a couple examples that we often see in the hospital. So definitely oxygen. Oxygen's tricky. Oxygen really isn't considered a drug because it's something we naturally need and breathe in. It's kind of part of our normal everyday to day. However, because it's used so much to supplement in the hospitals, we still talk about it. But one of our anesthetics we use is nitrous oxide or laughing gas. So again, it's a gas form. Then our liquids. So liquids are fluids, so they have a fixed volume, but they don't have a specific shape. So they can move and become whatever shape of the container they are in, but there is a fixed volume, unlike our gases that don't have a fixed volume or a shape. Now, pure liquids means that there are no additives, so just like water. So there's nothing added to it. A few different types of liquids we'll talk about. So we have volatile liquids. So these vaporize easily. So again, our gases are vapor forms of a liquid, but a volatile liquid just means it evaporates very quickly. So it goes from a liquid to a gas very quickly. So it's hard to kind of store that or work with it sometimes. So vaporizers typically are needed to then change it from that liquid to the vapor form. Now we also have emulsions, and an emulsion are two liquids that don't combine very well. So they're heterogeneous. So again, like oil and water, those aren't drugs, but just as an example, that would be an emulsion. So what happens is we get the droplets of one of those is going to be dispersed throughout the other one. And so shaking it, or in some cases rolling it, helps with that. And if you've ever used a roll-on deodorant, that's why it's a roll-on. It's kind of a liquid, but we mash in some of the solids, anyways, or some of the other liquids. They don't mix very well. Now we also have suspension. So these again are still types of liquids. So we have our volatile liquids, our emulsions. A suspension is where now we're combining a liquid and a solid. So emulsion, two different liquids, don't really combine. Suspension, we have a liquid and a solid, but like the emulsion, they're not mixing well, so they're heterogeneous. So here the solid particles are dispersed in the liquid. So again, redistributing them, shaking them up really well before administering them is important. And then our last one is a solution, and this is where we have a mixture where we're easily combining those two things. So they're homogeneous. We can't see the separation of them. And whenever this happens, we have two terms: solvent, which is the substance in larger amounts, and then the solute, which is the one in less amount. And so if we're talking about two liquids, the solvent is the one that we have the most of, and solute is the lesser one. If we're talking about mixing a solid and a liquid together, then that solid, so like if we're making salt water, like saline solution, the solid, which is salt, would be our solute. The liquid dissolving it is our solvent. So we have a few different types of solutions. We have aqueous solutions, so aqua, thinking about water. So here the solvent, again, the larger amount, which is water, so it's the universal solvent. A lot of times water is used to make up these solutions, but not always. Elixirs is a sweetened solution that has alcohol as the solvent. So instead of using water, we're using alcohol, and we've sweetened it. So we've added some sugar to make it taste a little better. A syrup, also thinking about sugary there, this is where it's aqueous, so we're using water as the solvent, but again, we're sweetening it. So elixirs and syrups both have sugar added. The difference is the solvent. If it's alcohol, it's called an elixir, like cough syrups. Those are using water as the solvent. And then a tincture is whenever we're just using alcohol as that solvent, but we're not adding any sugar. Then our solids, so these have a fixed volume and a fixed shape. So they have a certain shape. They're not molding to their container. They are the shape they are. And of course, they're contained in a specific volume. So a lot of times, many of the drugs that we get are in a powdered form. And then that powdered form can be compressed into a capsule. So again, it's still packaged where we're not completely compressing it together, but we're coating it or covering it with a capsule. Tablets, that's the completely compressed form. A troche is actually kind of looks like a lozenge, which is one of our other one here, so like a cough drop or something. The troche just has a little bit, it's not quite as hard as what the lozenge is. And a lot of times these may require that reconstitution, which is adding the liquid to the solid to change it from a solid form to a liquid form. So if it needs to be given in an IV, we can't put a solid in an IV. So we have to dissolve that powder into with water or with alcohol, get it into a liquid form. So that's considered reconstitution. So again, that's adding that liquid to go back to a liquid. Then semi-solid, name kind of implies there, but it's somewhere between. So it's still considered a solid because it has that rather fixed shape and volume, but it's more creamy. So it's somewhere in between a solid and a liquid. So these would be things like creams and foams, gels. So again, they still kind of have a shape, but they're a little more fluid, so they can take on a few different shapes. So viscosity becomes a term here, and that's just the thickness. So if we're thinking about a cream, those are still pretty thick, or a suppository, pretty thick. But like a gel is a little bit more liquidy, so it's less viscous. That's not as thick is what some of like the suppository or our creams would be. And then this is just kind of a table, again, not a question, but just to kind of put all of this together. Again, gases are liquids in its vapor form. All of our liquids are fluids, but we have volatile fluids, which vaporize easily. Emulsions is when we're putting two liquids together, but they don't mix well. Suspension, we have a liquid and a solid that aren't dissolving well. Solutions is where we do get some good dissolving there of two substances, and it can be a liquid and a liquid, or a liquid and a solid could make up that solution. And then aqueous means that solution, the solvent is water. Elixir, we're using alcohol as the solvent, but we're sweetening it. Syrup, we're using water, that aqueous solution, again, adding some sugar. And then the tincture is where we're using alcohol as that solvent. And then our solids, again, we have a specific shape and volume. And then the semi-solid is somewhere in between the liquid and the solvent.